then I will start with my lecture. Okay. What's a decoder? So can you tell me what's a decoder? Anyone? Yes. What's a decoder? So today's lecture topic is a decoder. What is a decoder? It is an input pattern detector. It's an input pattern detector with n inputs and 2 raised to power n outputs. So can you see here? So now what I'm going to do, so it has n inputs and 2 raised to power n outputs. So what I'm going to do, so I'm going to copy this and paste this in my next slide. So control C, and then I'm going to do, so I'm going to paste it here. So it is an input pattern detector with n inputs and 2 raised to power n outputs. So can I say here, if it is an n inputs, assume that we have, this is my decoder now. This is now not the block diagram of a decoder. Everything is visible on the screen, yes or no? Please help me. If no one will if no one will reply me quick, the exam will be difficult. Yeah. Please, I don't want to call any name. So we are still now for 15 students. Okay. So it has n inputs. So now it is a decoder. So this is an n inputs. How many inputs are there? There are n inputs. So I can call this as an minus 1, an minus 2, and blah 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 until a1 and a0. How many inputs are there? Help me. There are n inputs. How many outputs are there? Can you tell me? Please be quick. Please be quick. How many outputs are there? Help me. So there are n inputs, and let's assume we have m outputs. How many outputs are there? M outputs. So the m outputs is actually y0. We call this as y1, y2 until blah 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 until y m minus 1. So this implies we have m outputs and n inputs. So what is m now? So what is m? M is actually 2 raised to power n. Any question? Any question? If I'm not hearing, because this seems like I'm talking to some walls, please at least answer me yes or no, please. Please have mercy on me.
Yes, Professor, understood.
Okay, it's clear or not clear?
Yes,
So
it's
can you
clear.
see here? Yeah. So the thing is, so please, now please, I want you at least something that I'm not talking to the wall. So please, so now we have, so the decoder is called as n to 2 raised to power n decoder. Okay, so now we have now different possibilities. So let's assume we have n. Okay, and now we have m. M is actually 2 raised to power n. If n is equal to 2, what will be the value of m? So m will be actually 2 raised to power 2. So it means we have 4. If n is equal to 3, what will be m? M will be now 2 raised to power 3, which is actually 8. What will be, if n is equal to 5, what will be m? Can you not tell me? Help me.
It would be 32.
Yes, it will be 2 raised to power 5, which will be equal to 32. Okay, so for this example, for n is equal to 2, so can you see here for this example? So this is what? This decoder will be actually 2 to 4 decoder. Then it will be what? Can you help me? 3 to what? Help me. 3 to 8 decoder, and this decoder will be actually 5 to 32 decoder. So in general, we can say, so a decoder has how many inputs? So a decoder has n inputs. So this is n inputs. And how many outputs are there? There are m outputs. And what is m? M is actually 2 raised to power n. So this is actually m is 2 raised to power n. Okay. Now in this example, can you tell me? So now what do you do? Now I may use some different colors. So now if you look at here, so I'm now using a color of red color. Maybe I'll now use a red color. So this has n input and m output. And what is m? m is equal to 2 raised power n. Okay. In this example, what is n here? Can anyone tell me in the last one? This one. So this is open. N is what? Help me. N is 2. And what will be m here? Please answer. Please answer.
It will be 4, 2 to the power
Yeah.
of 2.
Yeah. So yes, this will be now. So this will be actually m is equal to 2 raised to power 2, which will be actually 4. So we have 4 outputs. So m is now 4. Any question? Okay. Now if n is equal to 2 in this example, n is equal to 2. So n is equal to 2. So it means that there will be 2 raised to power 2. So what I'm going to do, so now this will be actually how many combinations? So this, what is this? So now n is equal to 2. And now m is equal to 4. So m is equal to 2 raised to power 2, which is equal to 4. Okay. Now if you draw the truth table of this thingy, so now the truth table of this will be actually, now this is now the truth table. So how many possible combination will be there? It will be actually 2 spot 2, which will be actually 4 possible. Any question? Any question? This is clear or not clear? Yes. Clear or not clear?
Clear, Professor.
Okay. Now if you look at here, we have now, okay, which decoder is this? So basically, if you look at the decoder, so if you look at the decoder, the block diagram, so what are the inputs to the decoder? Can you tell me what are the inputs to a decoder? So the input is actually A1 and A0, and the output is actually Y0, Y1, Y2, and Y3. Okay, so we call this as 2 to 4 decoder, and this 2 to 4 decoder has two inputs and four outputs. Okay, now what's a decoder? This is now we're going to like explain what's a decoder. So a decoder, it means that actually we have assigned a code to each output. So I will explain this with an example. Can you see here? So now if you look at here, now if you look at here, this example, in this example. So now if you look at here, okay. Now if you convert this, so what I'm going to do, so I'm going to have a red green thingy. Okay, if you convert this into, so control Z. If you convert this into binary 0 0, what will you give me? Help me. 0.
0.
Okay, so if you convert this into binary, so it means that, okay, 0. So Y0 will be 1. So Y0 is 1 because this is the binary of 0. Okay, now if you convert this into binary, the second thingy, the red one, what will be its binary? Help me. If you convert 0 into binary, please help me.
1.
1. So this is Y1 is 1. Okay, now what am I going to do? I'm now using another color. So I'm now making a black color. What is this binary? Can you tell me? What is this binary? 2, and then
2.
Y2 is 1. Okay, now if we draw it again, so now let's assume if we have this thingy, this purple, this color. So what is it binary? 3, and then Y3 will be 1. Any question? Any question? Now explain this with an example. Now let's explain this in an example. Okay, so what is a decoder? I'll explain this with an example, and this example will be there. So for that, I need to know the name of some students in the class. So assume there are 4 students. Okay, Ghala, and Ghala, James, Ghala, James, Kaiser, and Abir. Ghala. So let's assume we have this Y3. So let's assume Y3 is Y0 is now, you know what I'm going to do. So Y0 is Ghala, and Y1 is James. Okay, and then now we have this black color. Kaiser is Y2, and then assume that we have Abir, okay, which is Y3. So these are total students. Okay, now if you look at here, in this example, in this example, so we can say here in this example, we have assigned a code. So what I'm going to do, so now we have assigned a code to each output. And what is the output in this example? So the output in this example are the students. Okay. Now, what is the code for Abir? Can you tell me? Please go ahead. What is the code for Abir? Help me. It's so simple. It's there. So I'm not hearing you. Please
Zero
answer
zero
me.
zero one.
What is the code for Abir? Look at the color.
One.
It is no. The code for Abir is 1 1. So can you see here? Abir is 1 1. Kaiser is 1 0. James is 0 1. And Ghala is 0 0. Got it? No, so this is the code. So these are the codes. So these are the codes. And if I say, okay, now in this case, okay, assign a code to each output and only one output and only one output is enabled at a time. So we can say only one student. So now how can we interpret it? Only one student will raise his or her hand. Got it or not got it? If I say 1 0, if the code is 1 0, who will raise the hand? Please help me. 1 0. Who will raise the hand?
What? Karen?
Kaiser will raise the hand.
Oh, okay,
And if
first.
Kaiser, okay. Now, if the code is 0 0, who will raise the hand?
Gala?
Yeah, Ghala will raise the hand. So it means that only one student will raise his hand. So it is okay. One output is one, and all the outputs are zero. Any question? Got it or not got it? Okay. Now I'll explain this with the same thing. So now this output is one enabled at a time. Okay. Now if you look at here, so for the outputs, okay, please in decoder, please remember. So it means that in decoder, so this is very important. So in decoder, no two outputs will be enabled at a time. Only one output. So only one output is enabled at a time. So if we say if y0 is equal to 1, this implies that then what does it imply? If y0 is equal to 1, so it means that y y1 is equal to y2 is equal to y3 is equal to 0. Got it or not got it? So if we say if y1 is equal to 1, this implies that y0 will be equal to y2 will be equal to y3 will be 0. Any question? Should I got it? Should get it or not it? Any question? Got it or not got it?
Got it.
Okay, now can you see here? Now this is the how many possible output? Okay, how many possible output combination are there? Here n is equal to 2. N is equal to 2, 0, 0, 0, 1, 1, 0, and 1, 1. How many possible combination output? So there will be tools for m, which is actually 16 possible tools for 16 possible output combination. So in this case, we will have tools for 4, which is 16 for 4 output combination. Okay, and if it's 0 0, so it means y0 is 1, 0 1, y1 is 1, 1 0, y2 is 1, and 1 1, y3 is 1, and all of the remaining combination are invalid. Got it or not got it? Any question? Should we proceed? Is clear or not clear? Clear? Okay. Now I'll give you another example. Which decoder is this? Can you tell me? Which decoder is this? Can you tell me? How many inputs are there? Help me. Please answer me. Please. This is really. Huh? How many inputs are there?
Three input.
Yes. They are three inputs. So these are three inputs. So we call this as A2, A1, and A0. So three inputs. So n is equal to three inputs. How many outputs are there? Help me.
8.
Yes, eight outputs. And we call this as output as D0. We can call it D0, Y0, doesn't matter. D1, D2, D3, D4, D5, D6, and D7. So we have eight outputs. Okay, now can you see here? Now please look at here. Now if we go for this, so I'm now looking at the color of this color. What is this binary? Help me. 101. This is the number system. Yes. Anyone may answer. What is the binary of 101?
5.
5. So it means that D5 will be 1. Okay. Now, if you look at another example, what is this binary? Equivalent binary. And anyone may answer. 7. It means that D7 will be 1. Okay. Now, if you say, let's assume we give another example. So now we can see what is this thing? Help me. What is this binary? Help me. 3. So it means that now D3 will be 1. Any question? Any question? So now there is now a question of bonus mark. A question of bonus mark. Clear or not clear? So a question of bonus mark. So I'll explain this with an example. So question of bonus mark. Assume that n is equal to 6. What will be m? There are different parts. Question number 1. And if anyone who will answer all of these questions. Question number 2. What will be the output? What will be the output if the input is 101101? Anyone will answer this question in 10 seconds will get one bonus mark. Yes. So no one answer.
64 and 45.
What?
64 m is equal to 64 and the output will be 45.
Let's see. Let's see. Okay. Now let's see n is equal to 6. So when n is equal to 6, so now we want to see the inputs. So the inputs will be n is equal to 6. So the input will be A5, A4, A3, A2, A1, and A0. So 6 inputs. The decoder will be n to 2 to the power n. So this will be 6 to 2 to the power 6. It will be 6 to 64 decoder. And the output is, what is the output? Can anyone tell me? Help me. What is the output? Anyone, please help me. Starting from what? Yes. Y0, Y1, Y2, and blah, 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 and until Y62 and Y63. How many outputs are there? These are 64 outputs. And now can you see here? Now we have this thing. This is actually 1, this is 2, this is 4, this is 8, this is 16, this is 32. So can you see here? So now in this example, it will be actually 32 plus 8 plus 4 plus 1. If you convert this into binary, 32 plus 8, 40 plus 4, 44, and 45. So in this example, y45 will be equal to 1, and all indices is for I. So for I is smaller or equal to. So can you see here? So we can say, okay, for y, so you didn't give me the correct answer. So for all indices, I smaller or equal to 63, and I is not equal to 45. So I is not equal to 45. So all of this yi will be 0. You got it or not got it? So this may be the question in exam. Now you got it? How the question will be exam will look like. Any question? Any question from anyone?
سلام. لا لا شغل عدل.
Hello? Whose mic is on? Abir? Abir? Okay. Any question? Is it clear or not clear? Got it? So in this case, if we have 32 plus 8, so y45, so y45 will be 1. This means that all indices from 0 to smaller are equal to I smaller or equal to 32 and I is not in so far. Yi will be 0. So it means y0 will be 0, y1 will be 0, y2 will be 0, and blah, blah, blah until y44 will be 0. Then y45 will be 1 because only 1 is enabled at a time. Y46 until y63 all will be 0. Any question? Is this clear or not clear? If it's not clear, then I will proceed. Clear?
Yeah, clear.
Okay, now how can we design now, and the $1,000,000 question is this: how can we design this 2 to 4 decoder? Now this is just like from the behavioral description. So in the earlier before that, now we have described the behavior of a decoder, but now we want to realize the output, the circuit diagram. So now what is our objective? So now we want to design, uh, 2 to 4 decoders. Okay, and this is the truth table of 2 to 4 decoders. So this is actually, what is this thing? This is now truth table of 2 to 4 decoder, and we already explained it before. Okay, now can you see here? Okay, now what is, there are four inputs. Please, can you see here? So now what we see, so now I'm using the red color. Okay, okay. Now what is d0? So d0 is actually now a a1 and a0. So if you convert this d0, so d0 is, if you convert 0, 0 is actually 0, 0. So when it's 0, 0, it will be equally a1 bar and a0 bar. Okay. Now we want to say, okay, now we want to find expression for d1. This is a1, a1 and a0. What is the expression for 1? 1. The index is 1 now. It is 0, 1. What is the expression? Can anyone tell me? Help me. Please help me. Quick. If you want the exam to be easy, so please be quick. Yes. Where should I put a bar? Where should I put a bar? On a1 or a0?
A0. A bar. A1.
A1 bar. And let's assume we want to find the expression for like d2. So this is also a1 and a0. So this is 2. It is actually 1, 0. Where should I put a bar? Or a1 or a0? Help me.
A0.
A0. And now if we want to design this decoder, and then we want to say, so this is actually d3. What is the expression for dt? Help me.
A1. A0.
A1 and a0, because 3 is actually 1. So this is actually for a 2 to 4 decoder. Now let's assume if we want to design a 3 to 8 decoder. Okay, so now let's assume this is the 3 to 8 decoder. This is a 3 to 8 decoder. Okay, so now can you tell me what will be the expression for like d5? So d5. So d5 will be what? A2, A1, and A0. And if you convert this code of 5, so 5 is 101. What is the expression for d5? Anyone tell me? Help me.
A1 bar.
A1. And what about this 011? D3. So D3 is what? Help me. Yes. What will the expression?
A2 bar.
Mm-hmm. Got it or not got it? Okay. So now if you want to implement this thingy, so can you see here? So now this is the expression for this thingy. And now we have to write the expression. So we need, if can you see here? So we need what? So we need, and for D0, so this is so simple. So for D0, now if you go for D0, so D0 will be look like this. So this is D0 and this is 0 and 0. A2, A1 and A0. And the expression for D1 This is so simple. So this is so simple. So the expression for D1 will be what? This is A1 and A0. Any question and so forth, so on. Clear or not clear? This is clear or not clear? Yes, students.
Clear, Professor, clear.
So now can you see here? Now please look at here. So now please look at here. So this is D0. So now I'm going to do. So I'm now using different colors. I'm using different colors. So if you want to have, it's a 2 to 4 decoder. So this is actually A1 bar. This is A1 bar and a 0 bar. And if we go for D3, can you see here? D3. This is actually what? A1 and A0. Clear or not clear? And now if you look at here, so now if you look at for the red one, so for the red one, what was this? This will go here. What is this thingy? This is actually A1 bar. And now can you see here? What is this thingy? It will go here. This is actually A0 bar. Any question? Okay. Now if you look at here, now please look at here. This is the code for all this thing. Now I'm now looking interested in D5 here. The D5 is actually what? A2, A1 bar, A0 bar. A2. So this is what, where is A2? A2 is here. So A2 is here. So D5, actually, can you see here? This will be actually now. It is actually A2. The first thing is A2. The second thing is actually A1 bar. So the second thing is A1 bar. So this is actually A1 bar. So now I'm using another color. So this is actually A1 bar. Is coming here. And the third thing is A0. A0 for A0. So this third input is A0. And where is now A0? Sorry, D5. Okay. And now we have 101. And now we have A0. So the third input is now A0. So can you see here the third input? The third input is now this. Any question? So the green thingy, can you see here? The green thingy is now what? A1 bar. Any question? Clear or not clear? And now this is the $1,000,000 question. Anyone who will answer this question, anyone who will answer this question will one bonus mark in 10 seconds. Okay. So now this is if you want to get a bonus mark, please respond to me as quickly as possible. Clear? Okay. So assume that we have a decoder, and let's assume we have A6, A5, A4, A3, A2, A1, and A0. What will be the output? Can you tell me? Now this is not the bonus mark question. This is just like, what will be the output? Can you tell me? Help me. What will be the output? It's not a bonus mark question, but just like for your understanding. What will be the output? Starting from Y0, Y1. What will be the last output? Can you tell me? Last two outputs.
Y62 and 63.
Wrong.
1 to 8.
127. Oh, yeah.
Because the thing is, yes, we have 7 inputs now. In this example, we have 7 inputs. Can you see this is a very tricky thingy? So, and please remember for your midterm, midterm 2 det and the final. So basically, you need to be very cautious, because since this is online, so this will be a very tricky thingy. So this n is now 7. So we have 7 inputs, and now the output is, can you see here? Here we have 128 outputs. Anyone will answer this question in 10 seconds will get one bonus mark. Find the output when A6, A5, A4, A3, A2, A1, and A0 is actually 0, 1, 1, 1, 0, 0, 1, 1. Yes, your time starts from now.
Y59 will be 1 and the rest will be 0.
Okay, let's see. So now can I say, I don't know, can I see shape second?
Professor, shouldn't it be 57?
Okay, I will, let's see. I will see. And let's see. Let's do it now. Now I'm going to explain it. What is this? It is 1. So 1, 2, 4, 8, 16, 32, and 64. Okay? 1, 2, 4, 8, 16, 32, 64. It is actually what? 64 plus 32 plus 16 plus 2 plus 1. So 64 plus 32 is 96, 98, 99, and plus 16 is 115. This implies that for this y, 115 will be equal to 1 and all other yi's will be equal to 0 except for I is equal to 115. And now, any question? Am I right or not? Clear or not clear?
Uh, Professor,
Clear.
isn't I equal 114?
Hmm?
I is equal to 114, right?
No, it is 115. Who said 114?
Because, okay.
Because the number is odd or even, the number is odd because the least significant bit is 1. It cannot be 114. Independent of this thingy, it cannot be 114 because the least significant bit is 1. I hope I answer your question. Can you see?
Can you
Now I'm
repeat?
adding 1 plus 2, 4, 8, 16 plus 32 plus 64. This is clear or not clear?
Yes, this is clear.
This is clear? Oh, that's good. That's good. Okay. Now, another question. This may also be the question in exam. So what I'm going to do, so I'm going you to have the question of exam. And you know what? You can do this working at your on your paper, and then you have to write the answer in the space provided. And please remember, when you submit the answer, you cannot go back direct to the same question. Okay. So this you have to be, and then I will also use a second camera. I will also enable a second camera. So you cannot appear for an exam with a second camera. So this now the for the exam the rule will be now more and more strict. I'm sorry for that, but for online exam I have to do that. Okay, now if we say now we have another problem. So let's assume another question, and this may be the question in exam. This may be the question in exam. Assume that we have a5 a7 a6 until a0. So the output will be from y0 till y1 and until y255 because now n is 8. So we have 256 output. 2 square 8 is equal to 256 output. What will be the expression? What is the expression for y100? Yes. Can you tell me? So this is actually this is 1, 2, 4, 8, 16, 32, 64, and 128. So what is the expression? So what is 100? 100 is actually 0, 64 plus 32, 96 plus 4. So now what is 100? 100 is actually 64 plus 32 plus 4. So the expression for y100 will be, can you tell me what will the expression for y100? Please help me. I have solved it. Yes. Y100 is equal to what? Help me. Help me. If I'm not get an answer, the exam will be difficult.
A7 bar, A6, A5, A4 bar, A3 bar,
Yeah,
A2, A1
A7
bar,
bar, A6, A5, A4 bar. A3 bar, and then A1 bar. Any question? So these are all the questions that I'm posting, and I will also post the working on iLearn. So these are all the expected questions that you may face in an exam. So they will be very short questions and very conceptual questions. Got it or not got it? So this will be very short question. Maybe there are 30 questions, maybe there are 40 questions. So you have to go through all these questions very quick. You cannot backtrack. Backtrack is not allowed. Okay. Any question? Should we proceed? Okay. So this is how we did it now. So now what we are going to do? So now what I'm going to do? So now this is our decoder. And this is the same thing that I explained for the next previous class, so I can put all the things here. So this is decoder, so it is 0 0. Okay, so please remember, so if we have 0 0 here in this example, if A is B is 0 0, so 0 0 this will be 1. If it's 0 0, it will be 1 and thing. So let's assume if A is 1 and B is 0, A is 1 and B is 0. So in this case, this decoder will be enabled. Can you see here? Now, in this example, can you see here now? Now I'm using the red color. A is 1 and B is 0. So this decoder will be enabled. Why? Because 1 0 means it is 1 and 2. So this is equal, this, if we convert this into binary, it is 2. So it means that y2 will be 1. Y2 will be 1. Since y2 is 1, so this gate will be enabled, and this gate, the other gates will be enabled or disabled. Anyone help me? These are disabled. Why it's disabled? Because it's 0. This is disabled. Why it is 0? This is disabled. Why it is 0? Any question? Clear? Or no? Now there is another $1 million question. Another $1 million question. The question is that how can we implement a logic function using decoder, and how? Okay. Now, how can we implement a logic function using decoder, and how? Okay. So now, and this is another question. So can you see here? This is copy, and then I'm pasting it here. Okay. Now, can you see here? Which decoder is this in this figure? Can you tell me? Please help me. Which decoder is this? Which is shown here? Which decoder is this? Anyone please help me? Which decoder is this? I'm not getting an answer from anyone. Yes, Abir, Anas, Fiza, Ghala. Do you hear me?
Yes.
Okay, please, why don't you speak? You have to be very, you need to, you put your hand on the mouse and then you can. So now what I'm going to do, so now it's a 2 to 4 decoder. It's a 2 to 4 decoder. So the question is this. Now we have another question. How we want to implement a logical function. So let's do how can we implement an exclusive OR gate? Okay, what is the output of an exclusive OR gate? So this is now the output, the exclusive OR gate. So how can we implement an exclusive OR gate using 2 to 4 decoder? So this is an exclusive OR gate. So this is now an exclusive OR gate. Let's assume the input of this exclusive OR gate is A, and then the second input is B, and now the output is C. How can we compute C? So C is now what? C is now equal to A bar B plus A B bar. Okay, now can you see here this A bar B is actually equal to 0 1, and then A B bar is actually 1 0. So can we write something like this? It is actually what? It is actually 0 1. It is actually M1 plus what? It is actually M2. So what is C now? So C is now sigma M of 1 and 2. Got it or not got it? So if you want to implement this thing, so this is actually C is now equal to M1 plus M2, and now each minterm will be provided by the output of the decoder. So we want to implement this thing. So what we need to do, so we need to put an OR gate for here y1 and y2, and then we put it here, and this will implement what? This will give me C. Okay, now what should I give to A1? So A1 will be connected to A, and A0 will be connected to B. Got it or not got it? Any question? Clear or not clear? This is clear or not clear?
Clear.
Okay, now this anyone. Okay, now can you see here? Now this is another example. So this is another example. So we did it. So now this I did it for the other class. So this is another. So we did it. So this is M1 plus M2. Okay, now can you see here? Okay, which gate is this? Y. Which gate is this here? Help me.
XNOR.
Yeah, it is XNOR. So this is an XNOR gate. So this is an XNOR gate, and this, can you see here, XNOR gate? So this XNOR gate is actually AB. AB is actually 1 1, which is actually M3, and M0. This is now M0. A bar B bar is M0. So it is actually M0 plus M3. So how can I write Y? So Y is now in this example. Can you tell me Y? How I can write in sigma form? Y is now equal to sigma M of what? Help me. 0 and what? 3. And how can we get Y? So Y is equal to M0 plus M3, M0 plus M3, and now this is M0, which is M0 is now in this color. This is M0 and now this is M3. Any question? Clear or not clear? So this is how we can implement an exclusive OR gate using a decoder. Okay, $1 million question. $1 million question. Okay, so okay, now the $1 million question. Is it visible? The screen is visible to you? Yes or no?
Yeah.
Okay. So the question is this: how can we implement a full adder using 3 to 8 decoder? How can we implement a full adder using 3 to 8 decoder? So now this is the truth table of a full adder. Can you see what are the input to the full adder? So now this is my full adder, and remember, in the full adder the input is A, B and C in. What is the output? C out and sum. Can anyone tell me what will be the expression for C out? Can you tell me? Help me. What will be the expression for C out? Help me in sigma form. Sigma M what? Help me. I'm now using the blue color. If so, if I convert this, these are the minterms 0, 1, 2, 3, 4, 5, 6. Okay. Can you see? Now this is C out, this is C out, this is C out, and this is C out 1. How can I write it? Help me. What can I write? C out is equal to sigma M of what? If I
3
will not get
and
3,
7.
very good. 3,
5, 6 and 7.
6 and 7. Okay. What will be the expression for sum now? Yes, help me. So
1,
sum
2,
is 1, 2, this.
4 and 7.
Okay. So this is actually the expression for this will be so the expression for this will be 1, 2, 4 and 7. 1, 2, 4 and 7. Any question? This is clear or not clear? Yes or no? Okay. Now what I'm going to do, so I'm going to copy this and paste it here. Okay, now how can we implement this using 3 to 8 decoder. So now for 3 to 8 decoders, now if you want to go for a 3 to 8 decoder, what will be the input of a 3 to 8 decoder? Can you tell me it is actually what? A2, A1 and A0. Then we have what? Help me. D0, D1, D2, D3, D4, D5, D6 and D7. Okay, how can we implement C out? C out is actually what? Can please look at here. So now we are using the green color. It is actually D3, got it? And D5, then D6, and then D7, and the output is what? Help me. C out. Any question? Clear? What about sum? Can you tell me? Now you're using the red color. What should I do? Help me. D1, which is actually D1 plus D2 plus D4 and plus D7. And now this will give me what? Any question? So this is what? This is actually D1, this is actually D2, this is actually D4, and this is actually D7. Any question? This is how we can implement a logical function, and in this case we have a logical function of a full adder. So we draw the truth table, identify the minterms, and then connect all of these minterms to an OR gate. Any question? Should we proceed? Any question? If I'm not hearing an answer, this is not good. At least I need something. Is it clear or not clear?
Yeah, clear.
Yeah.
Good. Okay, now this is another $1,000,000 question. Okay, so let's assume if you look at here, we want to implement this truth table. We want to implement this truth table. Okay, can anyone answer me how many inputs are to the system and how many outputs are there? Can anyone tell me? Help me. And please, I want to get the answer. If you want an easy exam, so please, I want a quick answer. So how many inputs are there to the system and how many outputs? So this is now the block diagram. Can anyone tell me? Help me. How many inputs?
3,
3 inputs. What are the name of these inputs? Help me.
A, B, and C.
A, B, and C. And how many outputs are there?
3, F, G, and H.
F. Okay. What is the color of F? What is the color of G? At least this is very simple.
Blue color.
Yeah. Got it or not got it? Okay. Now if you look at here, so now the first question is this. How many decoders are required here? Can you tell me how many decoders are required here?
8,
No. Only one decoder is required. Why 8 decoders are required? We require
yeah.
so the answer, so we need one decoder. Why we need one decoder? Because you need only one decoder. So this is my answer. So we need only one decoder. Okay. What type of decoder? How many inputs are there? 3. So there are 3
3,
inputs.
3 to
So
8.
we need so we need 3 to 8 because there are 3 inputs. So there are 3 inputs. So we need 3 to 8 decoder. Any question? Got it or not got it? Okay. How many OR gates are there required? How many OR gates are required? 3 OR gates. Why? Because there are 3 outputs. If there are 4 outputs, we need 4 OR gates. And how? Let's see. Now we are going to solve this question. So now we're going to solve this question. So what I'm going to do, I'm going to copy and then I'm pasting it here. Can anyone tell me what will be the expression for F? Help me. Red color. What will be the expression for F? Help me. Sigma M what? Help me.
256.
Very good. Very good. Thank you. Thank you. I really like your. And now what will be the expression for G?
0, 1, 2, 4, 5, 7.
0, 1, 2, 4, 5, 7. And what is the expression for H?
0 and 5.
0 and 5. Got it or not got it? So now we need a decoder. I told you we need a 3 to 8 decoder. So since we need a 3 to 8 decoder, so now this is actually what? A2, A1 and A0 and the output is actually D0, D1. Okay, so what I can do? I need to draw it bigger. So now can I see what I can do? So now I can this. Okay, so now what I need to do? So I need 3 to 8 decoder. The input is actually A2, A1 and A0 and the output is actually D0. You can call it D0 or Y0, doesn't matter. D1, D2, D3, D4, D5, D6 and D7. So these are the outputs. Okay, now what we need to do, so we have A2, A1 and A0. What should I connect to A2? Can you help me? What should I connect to A2? Help me. Looking at the truth table, please help me because you know this is very important. Labeling is very important. What should I connect to A2? Yes. No one is answering me. James, Ghala, Fiza, Kaiser. What should I connect to A2, A1 and A0? How many inputs are there? A, B, C. So what we need to do is we need to connect A to A2 because this is 3 to 8 decoder and B to A2, B to A1 and C to A0. And now we want to implement F, which is the red color. So I'm now using the red color. So what is F? This is actually what? D2 plus D5 and plus D6 and we need an OR gate. And the output of this is what? Any question? Do you hear me or not? Do you hear me or not? I'm not hearing any answer.
Yes, we can hear you.
Thank you. Thank you. Okay. How can we get G? How can we get G? Help me. Okay, now please, now we want to solve for H. How can we? So it is actually D0
And D5.
and D5. This is now my H. What about G? Okay, so for F, please now remember. So for F, we need a 3 input. So can you see here? For F, we need a 3 input OR gate. For F, we need a 3 input OR gate. For for H, we need how much input OR gate? Can you for H help me?
2 input.
OR gate. And for G, we need what? Help me.
6 input.
Yeah. So the question is that, can we reduce the cost? This is a $1,000,000 question. Can we reduce the cost for G? Anyone may answer. Can we reduce the cost for G? Anyone may answer. Yes. And how can, if and anyone will answer this question may get one bonus mark.
By sharing 5.
No. No. Okay, now what are you going to do? So now we need for G. So for G we need and it's a second for okay. So basically we can connect D0 plus D1 plus D2, but I'm not going to draw the gate because it will be too messy. How can we reduce the cost for this? Can you tell me?
By sharing it with H.
No. Okay. Now what I'm going to do? I'm using another thing, and then I'm now going to give a track now. Okay. Instead of finding the expression for G, why don't we need to find an expression for G bar? What will be G bar now? Can you tell me? Now I'm using another color.
3.
Right?
7.
Okay. So now what I'm going to have for G? Okay. So I'm now computing G bar. What will be the value of G bar? Help me. In the first entry, it will be 0. The second entry, help me. 0. Then 0. Then
1
1.
0
0.
0 1 0.
1 0. Okay. Now what I want to find. So now what I'm going to do. So now I'm going to take a screenshot of this. Okay, now we want to find an expression for G bar. And I'm going to like, what will be G bar? Can you tell me what will be G bar? Can you tell me? Help me. Sigma M what? Help me.
3 6.
Very good. 3 6. Got it or not got it? So for G bar, so please remember, for G we need a 6 input OR gate, but for G bar we need what? Help me.
2
Anyone?
input
Anyone may answer. 2 input what?
OR gate. AND gate.
No, OR gate. This is sigma. No, this is sigma M. For I'm talking for G bar. So for G bar, we need a 2 input OR gate because this is sigma M. Okay. Now for if you want to get G, what we need to do? Help me. So can you see what is G bar now? We want to compute G bar. So for G bar will be actually what? D3 and D6. And when we have this OR gate, so we get G bar. But when we want to convert it into G, we need another inverter in the output. Got it? So when we need another inverter in the output, so we basically we put a bubble here. So this is actually this. In the absence of this inverter, it will be G bar, and now it will be give me G. Any question? Clear or not clear?
Clear.
Okay. So now what we did? So we replaced for G. For G, we replaced a 6 input OR gate with a 2 input NOR gate. Which implementation is better? This implementation is better, the first one or the second one? Help me.
The second one.
The second one. Now a $1,000,000 question. Now a $1,000,000 question. So this is how can we reduce the cost? Yes, this is all the thumb. This is for the other students. So this is G is equal to 6 input OR gate, and now we explain this thingy. So now it is G bar, which is like 3M. So to implement G bar, we are interested in G. To implement G, we need a 2 input NOR gate. Any question? Clear or not clear?
Clear.
Clear. Instead of 6 input OR gate for G, we can use 2 input NOR gate for G. So now $1 million question. Then how can we, okay, now, so then this is $1 million question. So can you see here? So now we have this H, and then for G bar, so what we need, we convert it into G bar. G bar is in which color? The red color. Any question? This is clear or not clear? Clear?
Yes.
Okay. Again, another example. Now another example, the same thing. Please remember, we already did all the example that was done in the previous code. Okay, what was the code for Gala? Remember your code. Everyone remember your code. Remember the code for, I assigned some code to each student. Remember? So please remember your code in the first lecture, in the first slide. So Ghala is 00, James is 01, and please tell me your code. Ghala is 00, James is 01, Kaiser is 10, and Abir is 11. Please remember the code. Now I'm going to explain some more concepts now. Okay, now we have a 2 to 4 decoder with an enable signal. So can you see? We have a 2 to 4 with enable signal. So what I'm going to do, so I'm going to copy this and I'm going to paste it here. So in the 2 to 4 decoder, so can you see here? The 2 to 4 decoder, a classical 2 to 4 decoder does not have any enable signal. But now in this case, now we have an enable signal. Okay, now please remember in the previous example, what was the code for Gala? Please help me. What was the code for Gala?
0011M.
So okay, now just give an example. So the code for Gala was 00. So let's assume this is Gala. Okay, now let's assume this is Abir. It is 01. So 00, this is 01, and D2, let's assume Kaiser. I am now assigning a different code. So this is 10, and now who was the fourth one? James. James is now 11. Okay, now in this case, now there is an additional signal which called is enable. Oh, this is an enable signal. So now this enable signal is like me. I'm the guy. I'm the professor. So this implies that if enable is equal to 1, and if I say 01, who will raise their hand? Help me. 01. Abir will raise her hand. And if enable is equal to 1, and the code is 11, who will raise the hand? Help me. 11. Please quick, because I have very less time. Who will raise the hand? James will raise his hand. What about now? Okay, if enable is equal to 1, so it means the professor give the permission. So enable is 1, professor give permission. Okay, and perfect. Okay, what if, then a $1 million questions, what if enable is equal to 0? So if enable is equal to 0, so it means that professor is not granting any permission. So professor is not granting any permission, is not granting permission. So it means no one will raise their hand, independent of the code. No one will raise hand. Got it or not got it? So I will explain this with an example. So now even if, so now we have this 2 to 4 decoder. So let's assume we have 2 to 4 decoder. So now if we have 2 to 4 decoder, and let's assume if enable is equal to 0, it means professor is not granting the permission. And the code is A1 and A0 is 01. A1 and A0 is 01. Who will raise their hand? 01 is Abir. So it means Abir should be allowed to raise his hand. But now even in this case, D0 will be 0, D1 will be 0, D2 will be 0, and D3 will be 0, because now professor is not granting any permission. So now in this case, we ignore A1 and A0. So if we ignore the code and all outputs are 0. Any question? Any question?
No.
Is clear or not clear?
Clear.
Very good. Now at least I get some answer. I'm very happy that at least I get some answer. It is clear. Good. Got it or not got it? This is another example for the other students, and then okay. Now another question is this: how can we build? How can we build a larger decoder using smaller decoders? How can we build larger decoder using smaller decoder? And now this is a very tricky question. Got it or not got it? So now what I'm going to do? So now I'm going to copy this. Okay. So copy and distribution. Okay, can you see here which decoder is this? Can you tell me which decoder is this? Please be quick. I do not have any time because I will finish. Which decoder is this?
3
How many
to,
inputs and how many outputs? Huh?
3 to 8.
Yes, very good. So we have 3 to 8 decoder. What are the inputs? A2, A1, and A0. What are the outputs? D0, D1, D2, D3, D4, D5, D6, and D7. Got it or not got it? Okay. Now, can you see here? Now, this is very tricky now. This is now very tricky. Now, I'm using different colors. Why I'm different colors? Because colors are always good. So now what I'm going to do, so now I can use different color. I'm now using a red color. Please look at the red color. If you look at the red color, which decoder is this, the red color?
Two to 4.
Yes. And now I'm using another color. I'm now using a blue color. Which decoder is this?
2 to 4.
2 to 4. Got it or not got it? So for now what I'm going to do, we want to implement. Okay, now what is our objective? Our objective, so first we need to write our objective. So our objective is to implement. So our objective is to implement. So implement 3 to 8 decoder using 2 to 4 decoders. How? I will see. So we want to implement a 3 to 8 decoder using 2 to 4 decoder. Okay, now this red color is the top decoder or the bottom decoder? Red color, help me. This is the
Top.
top. And now the blue color is now the bottom. Got it or not got it? Okay, now please look at the 2 to 4 decoder and the top color. So now can you see here for the top color? So I'm now using a red color. Okay, now is this 2 to 4 decoder has some outputs actually D0, this is D1, it is D2, and this is D3. And now the internal input is actually A1 and A0. And even for the bottom decoder, I'm now going to draw it using the blue color. So the input is actually A1 and A0, and now the output is actually D0, D1, D2, and D3. So this is the internal block diagram of a 2 to 4 decoder. So we have a top 2 to 4 decoder, and then we have a bottom 2 to 4 decoder. Got it or not got it? Okay. Now the top 2 to 4 decoder is now depending on A1 and A0. So now this is A1 and A0. This is now A1 and A0. So this is on A1 and A0. So this is now depend on A1 and A0. So now what I'm going to do? So now it depends on A1 and A0. A1 is connected here. A0 is connected here. Okay. When A1 is 0 0. So they are 0 0. So now what I'm going to do? So I'm using another color. So now if it is 0 0. D0 is 1. So 0 0 D0 is 1. Okay. And D1 and D2 is 1. Okay. Now if you look at here for the blue one, it all depends on what? Now I'm using this color, the light blue color. If it is 1 0, which output is 1? Help me. 1 0. D6 will be 1. So it means that if it's 1 0, it means that if it is 1 0, A1 and A0 is 1 0, so D6 will be 1. So we need to connect D6 to D2. So now this is my D6, and now D3 with D7, D1 with D what? D5, and then D4. And then we need to connect D0 to what? Help me. D0, D1, D2, and D3. Okay, but now, okay, when top decoder will be enabled? Can anyone tell me when top decoder will be enabled? So the question is now, now I'm using a red color. When top decoder will be enabled? Can anyone help answer me? Yes. When what? Help me. Another question. When bottom decoder will be disabled? So when bottom decoder will be enabled, it depends on actually A2. So when A2 is equal to 0, so I can say when A2 is equal to 0, so the top decoder is enabled. And when A2 is equal to 1, the bottom decoder is enabled. So it means that now we need an enable signal for both decoders. So we need an enable signal here, we need an enable signal here. And the top decoder will be enabled when A2 is equal to 0. So when A2 is equal to 0, so we need to use an A2 signal. So now we need an A2. Now I'm using the A2, and then we invert it, and it goes to the enable. And the bottom decoder will be enabled when A2 is equal to 1. So A2 is now connected here. Any question? Any question?
No.
Is it clear or not clear?
Yes.
Why do we invert it?
Because, okay, I will explain this with an example. No problem. I'll explain this with an example. Okay, now I'll explain this with an example. So what I'm going to do, so please remember, I'm now going to the thing. I'll explain this. I will explain this. Okay. So at this point of time, you will not be able to see the screen, but I'm now will enable the signal. Okay. So now what I'm going to do, is the screen visible to you now?
No.
No.
Okay. So now what I'm going to do, so I'm now sharing an application screen, and I'll explain this. No problem. Here, can you see here? Is the screen visible to you now?
Yeah, it's
Yes.
clear.
Okay. Now when A2 is equal to 0, please look at the green color. So A2 is equal to 0. So when A2 is equal to 0, can you see here? This A2 is now 0. So this decoder will be enabled. Top decoder is enabled. And it's 0, the bottom decoder is disabled. When the bottom 0 is disabled, so D4, D5, D6, and D7 will be 0. This will be all zeros. Got it or not got it? Got it? So top decoder is enabled and the bottom decoder is disabled. And then here. So let's assume the input is 0, 1, 0. So the top decoder is enabled because of an inverter. Okay. And then D2 will be 1. And all D4 to D7 will be 0. So this is here. Now assume another scenario. So all D4 to D7 will be 0 because the bottom decoder is disabled. Now when A2 is equal to 1, now A2 is 1. So since we are using an inverter, so the top decoder is disabled. So the top decoder is disabled. So D0 to D3 will be all zeros, and the bottom decoder is enabled, and it depends on the additional signal, which is actually A1 and A0. Got it or not got it? Any question?
Yes. Got it.
Got it? So this is how it works. Any question? Any question? So in the exam, I may ask you to implement a 4 to 16 decoder using 3 to 8 decoder. So I may also ask a question, implement a 32 to 5 to 32 decoder using 4 to 16 decoder. So this may be a lot of like question in exam, and then and how to connect it. So you can see there in the, so what I'm going to do. So